Yeah, so then I got off the dolphin and ate the beef jerky, and I told my sister, never call me that again. All right? All right, so, all right, today we're talking about the unit circle definition of trigonometric functions. All right, so this will be, we need our unit circle out.
So the back of our unit circle?
Whichever side, I like to have it all on one. But if one side's getting a little congested, then we need to go ahead and go to the other side. As you can see, what we're going to do today is we're going to put specific x, y points on every single one of those radian measures that you know oh so well. It did the first one for you at 0, all right? This is 0.10. So what I want to do is I want to see where this came from today. I talked to I talked to a student that went up to school in Cape Girardeau, and he said that their pre-calc B teacher, you had to memorize all the points as well. I assure you, between now and next Friday, I'm going to show you so many shortcuts to memorize all these points that it's going to be easy. We don't have to worry about memorizing this whole circle, but rather just have it as a tool for part of our assessments coming up. Okay. Now this is all going to be based off our 30, 60, 90, and 45, 45, 90 triangles. I don't know, we're not doing degrees anymore, but so you guys told me that this was 2x, x, and square root of 3x, right? And so what I'm going to do is I'm going to move that triangle over to the unit circle right here. I'm showing you where it comes from. If you want to draw the triangle, you can. I'm not drawing a triangle at every single point. I'm going to do about 3 of them, and then I'm going to fill you in, just so you know where it comes from. I hate putting stuff up there and just saying, trust me, that's what it is. Okay, so remember, this is called the unit circle because everywhere on this circle, the radius is 1, meaning that my hypotenuse right here has to be 1. Which it makes sense that if the radius is 1, that this goes to the point 1, 0 as well. More on that coming up. But so what I need to do is I need to take this 30, 60, 90 triangle, and I'm going to move it over, but the hypotenuse is not 2x anymore, it's 1. So what can I do to 2x to make it turn into a 1? That's interesting. I never even would have thought about that. I think that's what last hour was mumbling, and I didn't understand what they were saying. Jared said, make it so the x value is 1/2. I like that. I was thinking just divide everything by 2x, which would give me the same idea. But let's go with Jared's. Let's make all these x's 1/2. Okay. Do you guys agree that if I make the x 1/2, that makes my hypotenuse 1, right? What does that make my right side over here? Just 1/2. And what does that make the bottom side? Okay, I'm going to call that the square root of 3/2 then. Okay. So what specific point does pi/6 map to? Well, if I'm starting right here, this is the origin, 0, 0. I went to the right, square root of 3/2. That would be my x coordinate. And then I went up 1/2. That would be my y coordinate. You might be sitting there thinking, man, what is that bald man talking about? I'm going to do it again. We'll go green this time. And I'm going to go to 2 pi/3. Now, these triangles I'm drawing are called reference triangles. If we make it to the end of this lecture, which we may or may not, we're going to use that word reference again. And the idea is that the one leg of the reference triangle is with the x-axis. Always the x-axis, never the y. Now, what type of triangle do I have this time? It looks like the same as this blue one. I just turned it a little bit, right? So it's another 30, 60, 90 because I'm 60 degrees up from this bottom. Now, again, I'm on the unit circle, so my hypotenuse has to be 1. So I'm going to use all of Jared's same values again, where across from the 30-degree angle, I have 1/2. And across from the 60-degree angle, I have the square root of 3 over 2. So what unique point does 2 pi over 3 map to? Well, I went to the left 1/2. Well, that's weird because I'm going to the left this time. How can I show I'm going to the left on this coordinate plane? A negative. Anytime I go to the left or down, it's going to be a negative. And then I went up square root of 3 over 2. So that's what we're going to write down at 2 pi over 3 on our unit circle is that negative 1/2 square root of 3 over 2. Do what? There's not exactly my point, and that's why I'm going to have so many shortcuts to show you over the next few days. Because you're right, we got the same values right here, didn't we, on these 2 points? We're just going to mix positives and negatives, and there's one other triangle that we did. We did a 45, 45, 90 triangle, didn't we? Mm-hmm. And that's what I'm about to do. So I'll just go ahead and draw this. I'm going to draw it down here in the 3rd quadrant. So again, this angle is going to be 45 degrees, and this is 45. But again, we're on the unit circle, meaning that my radius has to be 1. Meaning that this radius over here is not going to be 2x, but rather it's going to be 1. How do I change this hypotenuse right here down to 1? Divide by square root of 2 over x, right? Okay, and that would have worked up here as well. I just divide everything by 2x. So yeah, if I divide everything by the square root of 2x, that gives me 1. And so I just need to scale down my triangle and divide this by the square root of 2x. And divide this by the square root of 2x. And that'll make it so that this 45, 45, 9 triangle will fit on the unit circle. Help me out here. What is x divided by square root of 2x? Okay, I heard you say x on top and bottom right there, so those are going to cancel. So I'm just left with 1 over square root of 2, right? What's wrong with that? Good. No square roots on bottom. So that's going to give me square root of 2 over 2. And that'll be for both of my legs right here. Square root of 2 over 2. Square root of 2 over 2. Now hold on, I went to the left. So what does that mean? Negative. And then I went down. So it's also negative. So this point at 5 pi over 4 is simply negative square root of 2 over 2, negative square root of 2 over 2.
So 45, and then all the others are probably just going to be like square root of 2 over 2, square root of 2 over 2.
Awesome. That's good that you see that, right? Miller said that every pi over 4 or 45-degree angle in each quadrant, I would just be drawing this 45, 45, 90 triangle in every quadrant. And so all of them would have to be square root of 2 over 2, square root of 2 over 2. Square root of 2 over 2, square root of 2 over 2. However, they have to be unique. So look, in this quadrant, I have to throw a negative in front of my x values. Just like I did in algebra, because I'm going to the left. Square root of 2 over 2, square root of 2 over 2. Which one's negative there? 7 pi over 4. The y would be negative because I went down. to get to it. I'm going to piggyback on what Miller said. He said it great. So everything that's over 6 is going to be this exact pi over 6 right here. This square root of 3 over 2, oops, 1/2. I just have to put the negatives in the appropriate places. And that one doesn't have a negative. I put a negative on it. So that means that everything that has pi over 3 in it has to be these two numbers, these two xy points, but just with the negative moved around. Like on this one over here, it's not going to have a negative at all. Nothing in the first quadrant is going to be negative. In the third quadrant, both coordinates have to be negative because you're going to the left and you're going down. And in the fourth quadrant, only your y coordinate is negative. That's a 3 over 2. We've made it to the quadrant angles. Remember, the radius on this circle is 1. So if I don't go left or right, but rather I go up 1 unit, I don't go left or right, that means my x-coordinate is 0. And if I go up 1 unit, my y-coordinate is 1. It has to be 0, 1. What am I doing different right here at pi? I'm going left 1. So I'm going to the left, that's negative. Which one gets a negative 1, the x or the y? The x. I'm going in the x direction. Negative 1, 0. So that leaves 0, negative 1 down here. Ladies and gentlemen, we have our unit circle. And you do not have to memorize these points. My job will be to make it so that you will know these points very well by the end of next week. And I promise you, you will. Okay? Do what? All those points? There's definitely a pattern to it. If I would have put this one down here in black, I mean there's an easy pattern to it. But I got my bike from Cape, and there was a young man in there went to school at Cape Central, and he said he had to memorize this whole thing. And he said, I still struggle with it, knowing where everything goes. And so the fact that all of these values keep repeating, I have a better way of showing you this that I'll either put on a video later, or of course we'll be talking about it over the next week. All right, so I'm going to pick on this pi over 6 right here, this very first one that we did. Okay, so I'm going to redraw that in just a minute, or I might just leave it there. See if I can. I already erased it. All right, I'm just going to start over. So what I want to be able to do is I want to be able to do sine and cosine of any of those angles that we just talked about on our unit circle. And like I said, I'm going to pick on pi over 6 first. That means I want to find, I'm going to do sine of pi over 6. Find what it is, and cosine of pi over 6. Now at pi over 6, I had this beautiful 3069 triangle. And you guys switched up my stuff so that it looked like this. Okay. And remember that sine is going to be opposite over hypotenuse. So I'm going to switch this to pi over 6 so we know which angle we're talking about. What's opposite that pi over 6? All right, what side is opposite pi over 6 over here? 1/2. And the hypotenuse is 1. So it makes it so my SOHCAHTOA is much easier, but there's so much more to it than that. hold on just a second. Cosine pi over 6. That's going to be adjacent over hypotenuse, right? What's adjacent to the pi over 6? Square root of 3 over 2. And the hypotenuse? 1. Guys, what was my coordinate point that I put right here at pi over 6? I promise you, all the way around that unit circle, every x value that you put down was cosine of that angle. Every y value you put down, the 1/2 right here, is going to be sine of that angle. So all the way around, we're just looking at cosine of t, sine of t. Okay? So let's try that again. I'm going to jump all the way over to 4 pi over 3. So what we do on our unit circles, we put our finger on 4 pi over 3. Where's it at? It's in the third quadrant down here, right? What is that coordinate we put on 4 pi over 3? Negative 1/2. That's my cosine answer. Negative square root of 3 over 2. That's my sine answer. Every time. Isn't that cool? It only gets better. So this unit circle is a big help for finding sine and cosine of all of these angles. Let me give you one for you and your buddy to work. Got negative square root of 3 over 2 and negative 1/2 on that. All right, so you and your buddy, you guys take pi. I want cosine of pi, and I want sine of pi. If you're watching this video, go ahead and hit pause on the video, and then we'll put the answer up here while you do. All right, so now that we know this, I want to revisit a problem from the first unit that we did. Before we get going, I need you to remind me, that's staying there. I need you to remind me of the Pythagorean identities, all right?
Sine squared plus cosine squared equals 1 plus,
Oh, he's fast.
1 plus tangent squared equals
Okay.
secant squared.
Okay. And so what we can do now is do these problems from the first unit a little bit better. In the first unit, I said just everything's going to be positive. Well, now that we have the unit circle, sometimes we see it's going to be positive, sometimes it's going to be negative. So with a little bit extra information, you'll be able to piece that together. Okay, so that's just a reminder of your Pythagorean identities. They're not going anywhere anytime soon. Okay. So look at A. Part A, it gives me cosine and I'm looking for sine. Do I have one of those identities that I just erased that deals with sine and cosine? Okay. They're using t, so I'll go ahead and go with them. Now, sine is what I'm looking for here, so I'm going to leave it alone. But cosine squared, if cosine is equal to 2/3, what do I plug in for cosine squared? 4/9. Okay, square the 2, square the 3, I get 4/9. And it turns in the exact same problem you guys did great on the quiz, or on the test, the ones that got to them. So 1 minus 4/9 is 5/9. I can take the square root of both sides, and what we're going to need to do is reach back into our pre-calc A pocket and realize that we are going to have plus or minus on this. However, it's not going to be plus or minus because it tells me with just a little bit more information that we are going to be in the fourth quadrant. So look at the fourth quadrant on your unit circle. And look at all the sign values. Remember that sign is all my y values in the fourth quadrant. Did you guys put down positive or negative values in the fourth quadrant for sign? Negative. So that means that this one has to be negative. Okay, that's the only difference. We get down to the bottom, we're going to have the plus or minus. I just need to figure out which quadrant I'm in, positive or negative. And I'll make that much easier on Thursday. Okay. All right, you and your table buddy, you guys tackle part B right here, and then we'll call it a day. So if you're watching this at home again, we're here today, hit pause. You try this on your own and see if you get the same answer that we did. I don't think I'm going to have time to cover reference angles, and I really need to before I get into the shortcut on this, where we don't even have to use the unit circle. So I will get to reference angles or post a video or something tomorrow, maybe after the quiz, a little before the quiz. If not, I'll just squeeze it in because my next lecture day is not nearly as long because I'm never deriving all those points again on the unit circle. So this is the homework. It doesn't take very long. It's not going to say come up with a unit circle forwards and backwards. It's just a lot of those. You just have to go find it on the unit circle, write down your answer, and just make sure you're checking it and you're getting it in the right spot, all right? We'll catch you guys next time if you're at home. And then I'll tell you, remind me to tell you the story that I just told them at the beginning of class that you guys caught the tail end of.